Numeric variable types. Predefined numeric variables can be any of the following. An Nci variable. These variables are set by MP when it reads the Nci file. Typically, each value on the second line of each two-line pair is associated with a specific predefined variable. The Nci reference volume in the MP documentation PDF lists all of the Nci G-codes along with the predefined variables assigned to each of their parameters. They can be a calculated variable. This type of variable is set by MP as the result of calculations it performs on Nci variable data. What would be an example of a calculated variable? I think this is important, so I'll make mention of it here. If we go and look at the post processor, when we start looking at kind of what I would term a modern post, there's a lot of stuff that goes on behind the scenes in order for Mastercam to make your life easy. So when we start processing motion, Mastercam's got a bunch of predefined post blocks that let us process motion data that's coming from the Nci file. And one of the things that you'll see that we do in a modern 4-axis post, we combine all of the output from these entry post blocks into a common post block, PNC output. So it doesn't matter if we're processing rapid motion, only Z rapid motion, linear motion, a Z move only, whether we are processing 5-axis, which is the call to PMX for vector processing, or arc output for PCirc, okay, PCIR. All of these simply call the same post block, PNC output. Why do we do that? We do it so that we can come up with a common routine for processing the data in the same way. You're going to see the same thing with the pre-process post blocks, PCirc0 and PLin0. We call P-motion setup. So all of this stuff happens kind of in the background as a result of the way that this post is laid out. It doesn't matter what type of motion we are processing here. First thing we do is we call the pre-process post blocks, which is P-motion SU. Stands for P-motion setup, by the way. So if we search for P-motion SU, this is where P-motion SU is defined. It's only called in two places. It is called, I shouldn't say two places. It's also called at the end of P-cut type. It's called for P-lin0, P-CIR0, and it's called at the end of P-cut type. P-motion SU sets our break lines type, and it sets the value of linarc. This is used for motion breakup. Why do we want to do motion breakup? Because we don't know yet if we're processing rotary motion or if we're processing standard 3-axis motion. If, for example, we are taking an arc and we are wrapping it around a cylinder, MP has to take that arc data and break it. And it does that by using break lines type and linarc. Linarc is the switch for linearizing arcs. So first we start out and we set them both to 0. Break lines type and linarc we set to 0. Then we have a logic condition. This is the logic test. If wrote on X. What is wrote on X? Wrote on X, rotation on X, is a generic flag variable. We use wrote on X to determine if we have a rotary axis present. So if we have a rotary axis present, a fourth axis, yep, that fourth axis, or this variable, gets set to 1. If it gets set to 2, it throws an error and it kicks us out of the post, by the way, because it's a 4-axis post. We can't process 5-axis motion, so we can't have a machine definition with 2 rotary axes. It's one of the limitations. But if we do have a fourth axis, then we check the cut type variable. So cut type gets set way before, and actually I can show you a little bit of where it gets set. Let me back up just a hair here. And I'm going to go to PNC output. When we're processing motion, and this doesn't necessarily include, at the tool change or the retract or all that stuff. What I'm talking about are moves that are generated by G0, G1, G2, or G3 in the NCI. When we're processing motion, we always call PNC output. And in PNC output, we call P common move before. P com move B. You'll see this in a lot of places. P com move B kicks off everything. So if we search for P com move B, I'm going to go up to the top of the post, put my cursor there. And we're going to search for P com move B. You can see that it's at the start of P tool change common. It is at not the very start, but it is in P tool change 0. Here's where it actually gets called. Or this is the definition, sorry, this is not where it gets called. This is where it jumps to, P com move B. But if I keep searching, you're going to see it's at the start of PNC output. It's at the end of P common drill B, the common drill before. So it gets called in a few different places. And it only does 2 things. It calls PXYZ out, and it calls PS inc calc. PXYZ out is the start of the cut type processing. MP, or I should say the structure of these modern posts, keep track of what type of output are we processing. Are we processing 3-axis motion? Are we outputting it standard? Are we processing polar? Are we doing axis substitution? Or are we doing vector output, 4-axis? Okay, so those are the type of motion it calculates. PS inc calc stands for the post block start of incremental calculations. Basically, PXYZ out calculates a bunch of stuff for us. And this is true because if you think about it, P com move B is called at the start of every motion command. So every G0, G1, G2, or G3 calls this first before we get to any output. So the first thing it calls is PXYZ out. So if we go to PXYZ out, this is where we start mapping coordinates. And mapping really does a couple of things. It is for determining what our cut type is. Is it tool plane positioning? Is it axis substitution? Is it polar conversion? Or is it a multi-axis path simultaneous 4-axis output? So if wrote on X, in other words, if we have a rotary axis If this condition is true, we're going to process everything between these two brackets. If this is not true, then we call the else command. And if it's not true, we process everything between those brackets. So once we hit PXYZ out, it's going to process one of these. It's either the if condition or the else condition. So let's assume for a second we don't have a rotary axis. If we're just processing 3-axis motion, it hits the else command and it does this. And this is one of the hardest things to wrap your brain around inside MP, is when we have these functions that act on a list of variables. So if we're processing 3-axis motion, we have this command here, xabs equals vector equate $. This is a sneaky function, because if you look up vector equate in the documentation, what you'll find is that this copies a list of 3 values that start with the variable on the right, and it copies that list into 3 values that start with the variable on the left. This is vector math, but it's just saying it's vector equate is like vector copy. Copy 3 values into 3 other values. This is essentially post shorthand in this case, because we're not copying necessarily a real vector. We're copying the x, the y, and the z value of a point to 3 other variables that happen to start with xabs. So this is the shorthand way of saying this. Xabs equals $, yabs equals $, and zabs equals $. This one equation right here performs this work. And unless you know that that's what the vector equate does, it can be hard to figure this out, because you're saying, well, hey, where does y and z get set? It gets set here. This one line sets x, it sets y, and it sets z. And the same thing happens down here with I out equals vector equate $. This again is shorthand for I out equals $, J out equals $, and K out equals $. We did all that with one line of code right here. And we just have to know that that's how vector equate works. Why does this function work for us? This function works for us because that's the way, number one, that MP was built, but also because x, y, and z $ are always defined in order. Inside MPDLL, these 3 variables were defined in an ordered list. MP makes use of variables that are defined in order. Anytime we have a function in MP that acts on more than one variable at once. That's why, even though they don't say it, if you look up here at these sections of variables, they're defined in order. And they're defined in order because we can then use them with a shortcut like vector equate. And it's important that you keep them in order. Now there are some that don't matter. Okay, sequence number, $. I can move this wherever. I can add a new FMT statement and it won't matter. I can add this here because it's above x abs. I can add something in between here because I'm not separating this list of 3 values. But if I do this, I just broke my post. I just broke it because every time I've got a vector equate command that calls x abs, it's going to load x $ into x abs. It's going to load y $ into my var, and it's going to load z $ into y abs. MP is a very simple language in some cases. At the heart of how it was designed to be simple. And because of that, we don't have data structures that you would find in higher level languages. When you start talking about a vector or an array, there is only a one-dimensional array in MP, and that array is an ordered list. If you break the order, you break the array. So this would have to either be ahead of my x abs, y abs, and I can have an extra space in here, that's fine, but I cannot define another variable in between these 3. So that's why when people start messing with these, I mean, you can change the formatting, you can change the format characters, all that kind of stuff. Just don't break the order. Some of these variables, these guys right here, lead, arcrad, feed, dwell, cantext, mr2, these do not need to be in order. How do I know that? Just because I know the post pretty well, and I've dug through all of this. But these, the arc centers, do. I out, j out, and k out are used in a vector equate function. So they have to be listed in order. Very important. So if you're going to add some stuff to this list like this, I usually tell people, wherever you see these dividing lines, that's a good place. Okay, so just as a general kind of best practice, if you see a dividing line like this, it's a good place to start adding new stuff. So I usually will do this. Copy that dividing line, and the number of characters here doesn't matter. This is just for visualization here. But then add your new stuff here. You know, make a new section for yourself rather than risking accidentally interrupting the order of this stuff down here. Okay, so in some cases, order does matter. String select tables, certainly. Order matters here. We'll talk about string select tables later. Where are some other places where it matters? Anytime you've got... Here's a good one. Oh, actually, that one's not necessarily that good. Yeah, anytime you've got variables that need to be in order, I like to at least let people know, you know, hey, don't break these up. And you'll see that with some stuff here. There are some other functions in MP that will read multiple variable values from a string parameter. And in some cases, you need to create an ordered list and tell it how many of those values there are. Can't remember if we have any more vector stuff down here or not. Probably not in this post. Some of these as well. So 2006 parameter line, 2007 parameter line. This is a list of variables. And it's a list in a specific order because we're going to read the 2006 parameter line. And that has a certain number of variables on it. If I screw up this list, if I put something else in here, you know, if I add another FMT statement in the middle of that, I'm going to break the logic that reads it. The 2004 parameter line, all of these values are contained on one string parameter line, and we extract them all in a certain order. So what you're going to see is this. If param code equals 20,004, slot equals rpar, s parameter 16. We just loaded 16 values from this string parameter into a list of variables that starts with slot. Down here, we're loading 8 variables from s parameter into a list of variables that starts with cut ability. And I'm sure you can guess pilot diameter starts a list of 11 variables that get read from this parameter string when the param code is 20,007. It's a good question from Jeremy. Are these values defined in the format assignments? The answer is yes. In this case, so there are 2 ways to define a variable. You can either include it as part of a format statement, which is a line, or a format assignment, which is a line that starts with FMT, or you can define it as starting in the first column and define it with the colon character. So this set of format assignment lines right here from 166 down to 1066 to 1082 define these variables. And not only did they define them, they also assigned them a numerical value. In other words, what is the rounding? Format statement number 2 is 4-place decimal for inch, 3-place decimal for metric. And you can see that these are all defined with that same, here's one where we've got a list, but some of them are defined as decimal and some of them are defined as integer. So format statement number 4 is integer. And we'll get into that as we continue to talk about numeric variables. Back to PXYZ out. If we're processing 4-axis motion, then we run this code here. And the first thing we check is cut type. Is cut type 0, cut type 1, cut type 2, cut type 3. So where is cut type defined? Well, cut type is defined earlier in the processing. So we'll search for cut type. And what I'm going to do here under PXYZ out, I'm going to select that line and then right click and go to bookmarks, and I'll toggle bookmark so I can jump back here easily. And we'll search for cut type. And what I'm looking for is cut type equals. So cut type flag. Oop. Well, it's going to be down here somewhere. You notice that it's referenced a lot. And I bet where we're going to see it defined is in P cut type. Yeah. So this is where we set cut type, is in the P cut type post block. So cut type. 0 is tool plane, 1 is axis substitution, 2 is polar, 3 is 4 or 5 axis. cut type equals rotary type. So you can see here that we have a predefined variable in MP that actually gets its value from the rotary axis dialog box. Where is that? Well, if we go back to the operation and we take this contour, for example, actually it could be any of these. We could wrap this drill op. So we go to the parameters here, we go down to axis control, rotary axis control, and this is where we choose either no rotation or rotary axis positioning, which is essentially the same, 3-axis, which is polar, or axis substitution. And we have to enter a rotary diameter and tell it whether we want to unroll it and which way to wrap it. And that is going to set this variable here to either a 0, a 1, or a 2. So if cut type equals 3, cut type equals 0. So this kind of resets it from the last time. And now, actually, sorry, this is also one of the options in the dialog box. It's weird. If you look at the dialog box, I think it goes like 0, 3, 2, 1, or something like that. So there's an option here that says, if it equals 3, make it 0. Then we test another predefined variable, $5 sign. $5 is a flag variable that gets set by MP. And it will automatically get set for you by MPDLL based on the type of operation that you're processing. Is it a 5-axis operation or not? 0 is not a 5-axis op. 1 is a 5-axis milling op. 2 is a 5-axis drill op. So it says if mil5, so if this is true, in other words, if it's not 0, we set this. We set if rotate on x equals 0, result equals, give us an error, mprint s-axis off, because there's no rotary axis, but it's mil type 5, and that doesn't work. And then it sets cut type equal to 3. If we're processing a vertical machine and M1 does not equal 1 and rot on x equals 1, so if the rotary axis, if we are rotating about the x-axis and the plane x isn't the same direction as the machine x, we're going to throw an error. So this is actually some logic that is looking at the way that your machine definition is set up and your tool plane is set up. There is a matrix that is used for the tool plane, and it's the variables M1, M2, M3, all the way up through M9 $. And each one of these holds the X, Y, or Z component of the X, Y, or Z axis. And that's a really weird thing to say until you start learning about matrices. So a matrix is a 9-variable array that holds the endpoints of the X, Y, and Z axis of your tool plane. Each one of the vectors that make up your tool plane is unitized. In other words, the vector length is 1. And we may talk about this maybe during some of our office hours. We tend not to get into a whole lot of vector and matrix math in this course. We save that more for the 5-axis and the multi-axis course, just because it's pretty math intensive, and MP does the work for you with a 4-axis post. This is all warning stuff, checking the VMC switch, which way we're rotating about, and it does some other setting up stuff. It calculates the feed rate, and it does the P motion setup. So this basically just sets cut type. Inside PXYZC out, based on the value of cut type, we call a different output post block. Or I shouldn't say output post block. different calculation post block. PXYZ out 0 is tool plane positioning. And this should look a little bit familiar, because what are we doing here? We're setting X, Y, and Z abs, and we're setting I out, J out, and K out. Okay, very similar to what we did up here for 3-axis. If cut type equals 2, and wrote on X equals 2, and VMC, we're calculating C dollar sign. C dollar sign is an important variable. For a 4-axis post, C dollar sign sets the rotation angle. C dollar sign is calculated based on the tool plane that you are using, and it is calculated by MP, and it gives you the raw rotary axis angle from 0 to 360 degrees. If rot on X equals 2, rot on X equals 2 is horizontal. You notice that we take C save and we set C save equal to negative C dollar sign. If we are not processing a horizontal, C save equals positive C dollar sign. This is where we set the rotary axis when we're processing tool plane motion. That's it. Now, C save gets manipulated later. Okay, and you'll see that C save gets set down here if we're in axis sub. C save gets set down here. This is still axis sub. VMC with rotary A about X. VMC axis substitution about Y. Basically, this is all this logic does is manipulate C save. So we end up setting this value, C save. Then later on, eventually we get to call PC out rev. Okay, and PC out rev looks to see how many revolutions we've done. And based on some settings in the machine definition, it chooses whether or not our axis is allowed to wind up. So in other words, are we allowed to go beyond 360 degrees? Can we go to 720? Can we go to 1080? Now this isn't a rotary axis limit. This is only looking to see what type of rotation do we output. So if you look in your machine definition and you go look at your rotary axis properties, axis supports continuous positioning. This means the rotary axis can rotate to basically any position. In other words, we don't have to index. Index means we can only rotate to fixed angles. Sometimes this is 1 degree. Sometimes this is 0.001 degree, but it is not allowed to rotate the axis while we cut. That's what this fixed/continuous means. So fixed means we can only rotate and we have to stop and do 3-axis machining. Axis supports continuous positionings means that the rotary axis can turn while we cut, and then we determine the output type. Signed continuous. This means we get plus or minus, and the rotary axis is allowed to rotate beyond 360 degrees. So we can go to 720, 1080. We can go up to, 28,000 degrees if we wanted to wrap multiple times. How many wraps are you doing? Just divide the value by 360. So, if you see that you've done, 23,658 degrees, 65 revolutions, 65 and some change. Okay, so whatever your rotary axis value, if you're wrapping beyond 360, you can count the number of revolutions. Signed direction, absolute angle. This setting here limits your output to 360 degrees plus or minus. So it actually gives you 720 degrees of total revolution, and the sign of the angle that's output determines direction, usually on the machine. So, positive, it's going to rotate, clockwise or counterclockwise, whatever. Let's say it rotates clockwise. Negative is going to be the opposite, counterclockwise, or vice versa. If clockwise, if positive rotation is counterclockwise, then negative rotation is going to be the opposite. Shortest direction, absolute angle, 0 to 360. Limits the values to positive only, 0 to 360 degrees. If you go beyond 360, it will wrap around to 0. So there's 3 different options right here, and whether or not the code is allowed to wind up is handled in PC out rev. Now eventually, go through this logic. And eventually we end up setting C-abs. Okay, so C-abs, C-absolute, is the variable that is going to output our rotary axis address. It doesn't matter if the prefix is A, B, or C. Internally, the raw angle is $, and the output is set in C-abs. So if you go up to the top where the formatting is, and you're looking at your rotary axis, and you see this C-axis position, even though the variable is C-abs, right now the prefix is set to output A. Okay, that is our A-axis rotary. The variable just happens to be named C. Why they picked that for the internal variable for all 4-axis rotation, I could not tell you. I don't know why they didn't just make, some logic for A, some logic for B, some logic for C. It really don't know, honestly. But that is the rotary axis address, or that is the rotary axis variable for output for 4-axis rotation. All right, well, we're coming up on the end of class for today. I'd like you guys to get a jump start, guys and gals. I can't remember if we have any women in this class or not. I don't like leaving anybody out. By the way, just to ask, just because I'm curious, are there any women in this class? Not that I'm like trying to judge you by your name or anything. I was just looking at the list of names that we had of people signing up, and I'm like 90% sure it's all male, but just in case, I missed you, I definitely don't want to always refer to, the opposite gender of who you are. So, anyways, I don't think we're getting any women like replying, but in case any women are watching the video, welcome. We want you to learn post just as much as the men, so hopefully you don't feel bad about that. Anyways, I'd like you guys to read through the variables and strings section. We're going to go through it, but kind of like we did with the post blocks, we're going to jump around a little bit. We're going to go through and do some practical examples and try to get you understanding numeric variables, string variables, formatting, okay, and the outputting. So we'll be going through more variable stuff kind of in depth next class section, and we'll probably get about halfway through class with the variables and strings, and then we're going to take a break from that, because this is all valuable stuff. It's important to know it. It's important to learn it, but it's also kind of heavy. If I'm being kind of honest, reading through all this stuff, unless you go through and work through a practical example, a lot of it's really dry. You know, it's really technical info, and until you get some experience of actually, you know, typing some code and making some edits, it's hard to put it all together. So, you know, that's partly what office hours is for, but I also want to jump in as well with the regular class, making post edits, going through, you know, taking an example, making some edits, writing code. I think that's really important to see. So are there any questions about the stuff that we've covered so far in class or today specifically? Let's go ahead and open it up for questions. Pause this for a second. Simple post edits you guys can try on your own. You can always start moving stuff around, which is a good thing to see. So if I go and I look at what I would do is I would look for stuff that is obviously an output line. How do I tell if it's obviously an output line? Normally starts with PBLD and $. What is PBLD? PBLD is the block delete post block. There's a post block that gets called on almost every output line that just goes and checks to see if block delete is turned on or not. And if it's turned on, it outputs a slash character. And if it's not turned on, it doesn't output a character. And then it has typically a sequence number and $, which may or may not output a sequence number. Depends if line numbers are turned on. Then you have some type of output, and then it ends in $. And if I wanted to break this up into multiple lines, usually I need to copy the PBLD and the $, and put an $, at the end of the line. And then anything in between there, I need to make sure I have at least one thing in here because I have a comma here and a comma here. I can't have just two commas in a row. This would throw an error if I had an output statement with nothing there. Okay? So I've got this comma here, and now I can take and say move SG plane down here, and let's move S abs inc and move it there. Oop. And save it. Another good one is to break up the tool change in the MO6. Gives you a chance to play with the existing codes, moving things around and seeing if you break anything. Remember to make a copy before you start. Got another question. What is PFBLD? Is that force block delete? Yes, that is force block delete. So force block delete is always going to output the slash if it's encountered on the post line. So why do we have this code here? G28, G92. Why do we have this? If you look at an operation in Mastercam with this post and you look at your MISC values, oh, do they not even tell you up here? Huh. Well, that's cheesy. Normally it's based off miscellaneous integer number 1. Let's see how they're setting WSCS type. Okay, so they're just initializing it here. Some posts will set WCS type in the operation, and they typically use miscellaneous integer number 1. This post has a variable at the top that you initialize. What kind of output do you want? Do you want work offsets, or do you want to use G92 with a home position? G92 is a method of setting a work offset on an older machine. And typically the way that you're going to set it is you're going to manually position the tool to a certain XYZ position away from where the 0 point on your part is, and you're going to call a G92. So if we were going to set this to G92 at the start or at the tool change, and change a value there, repost, and now we're going to get this G92 statement at the front before the tool change, and you notice that it forced the block delete because that's what's in the post code. And that's where this PF_BLD came from. So why do we have the call to block delete on all of these output lines? We have this call here because MP in Mastercam itself includes an option for outputting block delete. So for example, let's say that we were machining a casting and we wanted to drill a hole on the casting, but some castings had a lot of material. So we didn't really know where that surface was. Now on some of these castings, we can just drill it, right? There's no extra material, no problem. We just poke those holes in, boom, boom, boom. But then on some castings, we actually have to bring a tool in there and clean some of that up. So for operation number 2, I'm going to go to can text, and I'll choose block delete on, add before, and block delete on, add with. And this is going to put block delete on before the tool change and with the motion. And then in G81 down here in my drill cycle, I'm going to go into can text, and I'm going to set block delete off, add before. So now with that turned on, go ahead and post out those operations. And you can see that for the first operation, oh, you know what? Let's go change that switch back. Okay, so we'll go back to here, and you can see that basically this operation ended. We had our drill cycle, and then we turn on block delete. So all of this code for the tool change and for the entire operation, we can skip it on the control. We just turn on the block delete switch, and it just acts like it has 2 drill cycles. Does this drill cycle, hits the MO1, stops if we want it to, if that switch is on, and then it goes down here, and it executes the next tool change. So the reason that we have 2 different post blocks is that we may want to always output block delete. So in the case of our WCS type, here, when we output these lines of code, we always want to force block delete on. So that's why we're going to use PF_BLD. It's a place where we always want this code to come out. PBLD only outputs a slash if it's turned on with can text. So it allows us control. And the control that we get is controlled by the operations inside Mastercam. All of this code may or may not have the slash in front of it, depending on our can text settings. So even though we have all this code here, all this code could be output with a slash in front of it. The reason we have both of those post blocks is because with one, the output is always certain. We always want to force out the slash. In the other case, with PBLD, which is just the block delete post block, we only output the slash when that option is enabled by the operations in Mastercam. That's why we have the two differences. So if we go back into op number 2 here, and we go to can text, and we remove these, guess what? We no longer get them output in the code. I may have to regen them. No. So that's why we have the difference between the two. One of them, if we use PFBLD for everything, we would always get a slash on front of every line. And that's not really what we want. An asterisk forces the output of a variable. You cannot force the output of a post block. That's the difference. That's where you're missing it. So every time you see an asterisk, it is in front of a numeric variable or a string select variable. You will never see an asterisk in front of a post block. This is a jump. Okay? So this jumps somewhere else and performs some action. So if I call up PFBLD and I look and I keep searching through the post, I will eventually find the definition. Here's the difference between these two post blocks. They're not variables. PFBLD says force the output of a slash character. PBLD says if this variable is not 0, output a conditional slash character. Conditional meaning there must be other valid output on the NC output line in order for the character to be output. If there is no other valid output, you will not get just a blank line with a slash character on it. Okay? So this is something that's very common to see when people are learning to edit posts. They think this is a variable. It is not. Another example, pWriteBuff5, pTravel. These are calls. These are jumps to somewhere else. So what happens when we hit PSOF? We start processing PSOF. Probe head is a command variable. It tells MP to process probing if it's present. If it's not present, it doesn't do anything. pTravel. What happens when we hit this post block call? When we see a post block call on a line by itself or as part of an output line, we make the jump. So we see pTravel. pTravel is going to call another block. It calls this block here. So it jumps here and it executes all these lines of code, and then it returns from whence it came. So after we process that, it's going to jump back. So we processed pTravel, we've executed all the code inside pTravel, and any of these, so pWriteBuff5 may make a bunch of calls. In fact, pCutType does. So when PSOF is processing, it calls this, it returns. It calls this, it returns. It calls this, it returns. Then it calls pCutType. So pCutType jumps here. And then we start processing this. And there may or may not be more calls in here to other post blocks. In fact, there are. So we process all this, which is all just formulas and checking and error checks. We process all that data, and then we make a call. pfcalcumin. So pfcalcumin is defined here. So we set this value, IPR type equals 0. We set this value. We do these if checks. We set this. And if there were more post block calls in here, we would jump outside. There aren't, so we return, and then we call pMotionSU. So pMotionSU jumps here and sets these values, and then it returns. So finally, after we've processed all the code in here and both of these jumps, do we return from pcut type. So the MP posts make use of calling subroutines all the time. We're constantly jumping to somewhere and then jumping to somewhere else and then jumping to somewhere else, making a calculation, getting a value, saving a value, and then jumping all the way back to where we started and then processing the next line. So when we call NCI G code 1001 in the NCI file, that starts PSOF. PSOF is going to process a bunch of stuff. Okay? It processes all of this logic down here, including the jump to P tool change common, which actually processes all this logic down here. Okay, and after processing all that logic, this is the output. The call to PSOF generated all of this. Now, there were some jumps in there, admittedly. We called PSOF, that called P tool change common. So like all this stuff right here, this is all P tool change common. This stuff right here, pretty sure that's all, I shouldn't say that. I think this stuff's all P tool change common, and then, well, anyway. This stuff right here is all called from PSOF. It's all generated from a single NCI G code. That's it. Right? And then this starts the motion. So we're going to get a G0 for the first position. Then we're going to get a drill cycle. So that's where we call the G81. We repeat some drill points. We cancel the drill cycle. Then we get a G0 line, which retracts us to Z10. Shut off the spindle, retract. All of this stuff here is generated from P-retract. So this isn't part of the NCI output. This is all generated as a result of this operation ending and this operation beginning. And this is all generated, like I mentioned, from P-retract. In fact, it may include the Z10. I can't remember offhand. So there is some stuff that can be generated by your post based on an event taking place. An event like a tool change. There's other stuff that's generated based on actual NCI G code values that are in the NCI file. And we're running a little over tonight. So hopefully that answered all the current questions. I'm sure as we go through creating variables, learning how to format them, learning how to write post lines and post blocks, we'll go, there'll be more questions, I'm sure. So I think that's going to wrap us up for tonight. And I will see you guys on Thursday. So please do try to read up on variables, numeric variables, and string variables. And that is... looks like it starts on page 57 of the MP guide there. It's chapter 4. And let's see here. And it goes to about page 92 there. So 57 to 92. And that's right, we are doing a Wednesday. I did promise you guys that, so let's do this thing. So let me get this set up. Okay. Yeah, you guys are very welcome. Let me. Oh, copy this. Okay, yeah, thanks guys. I'm setting up an invite here. Can I do this? Can I take? Oh, of course not. Unfortunately. Okay, I'm going to go ahead and shut down the broadcast, guys, and I'm going to send out this invite for Wednesday. So let me go ahead and do that.